So, a couple weeks ago, on Twitter, some horrible time of the night, 9 o'clock, actually, that's pretty reasonable, I saw this tweet go past, and it's something that's a bit of a pet peeve. It's vendor going, we've got this great machine learning framework that will detect your anomalies and traffic patterns. It's like, here's one of our interconnects. It went from 0 to 50 odd gigabit. That's legitimate traffic. That is not an anomaly, or at least not a problematic anomaly. So of course I immediately responded with, well, okay, 2:30 a.m. That's totally immediate. Responded with, I've been tempted to write this as a bit of a conference talk, and in fact, Simon made the unfortunate post of, hey, we've got spaces for lightning talks just a couple of days later. So, hi, I'm Julien. I have opinions. Those of you who've met me know this. You're lucky you're getting the short version. So professional IT and operations, 2000-ish. I've been in networking at Google for a very long time. These days I do random infrastructure stuff, and my second full-time job is code shaving, and those of you here, my third full-time job is Secretary of Linux Australia. Please come to the AGM this evening. So there's two big things that often get called out as our solution can help you with this, and in my mind they just can't. Alert correlation is probably the big first one. Its basic idea is X is broken, Y is broken. Are they the same root cause? And there's a pretty simple example to show why this isn't obvious even when it's obvious. You have a city, or two cities. These will be network examples because I know how to write those trivially. You connect them by diverse network paths. You fail to check your vendors deeply enough, or they lie, or whatever happens, accidentally, oops, something got moved. And it turns out both your diverse network paths go over the same bridge. But they're still diverse because they're going over both sides of the bridge. And then say this bridge in a certain European city gets set on fire, as might have happened a couple of weeks ago. Is that a correlated incident? I mean, yes, in that the same root cause was both outages, but it wasn't meant to be one outage. They're meant to be diverse. In my history, I actually prefer getting the two alerts. I can look back later and discover, oh, they shouldn't have been correlated. We have a problem that's going to take months to fix. And in fact, that's my two outages. I lost a path, and I should not have lost two paths. But if you write a correlation engine, it might learn that those are totally correlated events, therefore you should only get one alert. But they shouldn't have been correlated. Useful correlation engines exist, but they tend to be pretty simple rule-based. And at the point your infrastructure is complex enough that the rule-based system is helpful, you probably have the intent databases that let you work this out, or at least a discovery system that lets you work this out. The standard basic hierarchy for network link level alerts was, we might alert on low optical power, but it's not worth alerting on that if the link's down. It's not actually worth alerting if a link's down if the entire bundle is down. And it's not even really worth alerting if the bundle's down if the entire optical span's gone down. And you can auto-detect chunks of this. Eventually you want full intent databases that you can hierarchy, but some of it you can detect. And for a really neat example that is not using any form of intelligence whatsoever, there's a system we built, it was just being built in 2011, where we combined a prober mesh with forced MPLS paths, so we could run a prober mesh over every single link, individual link in our network with some statistical checks so that bundles and other such elements where we couldn't target at a micro level, we could guess that we would have coverage. Then plug that into a linear programming engine that just went, oh, there is correlation on these 17 things that share only one component. That's probably the broken thing. we were finding packet loss of fractions of a percent. We were finding all sorts of absurdly, just very subtly broken things. And some of these would not be showing encounters. Some of them were just crazy. But it didn't require any machine learning, it just worked. The presentation deck from Nanog and the video from Aaron, annoyingly I don't have a set that matches both of them, are up there. This was developed by various people that I work with in Sydney. I was mostly just a user of it back a couple of years ago. And it's simple, well, it's PhD level math, but compared to actual machine learning complexity, it's fine. So anomaly detection is the other big thing that people call out with. We can identify anomalies. Yeah? So you start with a fire hose of information. Syslog collection, audit trails on things, packet captures. Find me some interesting things. Well, find me some unusual things, sure. But do they matter? At any scale whatsoever. It's not just needles in haystacks. There's probably some needles in there. It's needles in haystacks of fields of the size of Australia, and sure, there's some neat stuff in there. Anyone who's ever done the math on false positives, false negatives and tuning knows that very quickly you're just getting useless feeds. Just store the logs for later and grep. The amount of times over the years where the obvious panicking log message from a vendor device was telling me everything was fine, and the no, everything's just fine message is the one that's telling me the device is actually on fire, sometimes literally, is, yeah, you can't know this ahead of time. You can't use anomalies ahead of time. And okay, maybe you just store everything and go, we have used a fuzzy matcher. Here are the top 100 fuzzy matches of the day. Rank them, throw them out. Eventually do that and you run low on things. I mean, some of us use log check. I know of it as the Debian tool. I run this on my personal machine in harsh mode. And I eventually have regular expressions for all the normal stuff, so I don't get much email. But the reality is 99% of the email it does send me is still useless. I've just gotten used to it. That's really the short version. If you do have a counterexample for AI machine learning operations, I would actually like to hear it. If you want this as a longer rant, without just providing beer tonight, get in contact. We're gone. Thank you.